Welcome to MSM Solution YouTube channel, Quality Systems, Quality People. Please join me in a series of videos as we discuss quality control in laboratories. Remember to subscribe so you don't miss any new videos, and give this video a thumbs up if you enjoy it and would like to see more. What is our role as analytical chemists in the lab? Well, it is mainly to produce results. We do an analytical test and then give a lab report which contains those results. There is a lot that goes into producing this analytical report. It's not just about the final number. We have to ensure that the analytical result that we produce is both accurate and reliable. We need to look into aspects of time, cost, and quality, and all are just as important. You have to make sure that you meet your set turnaround time and also be cost effective. However, just as important is the focus on quality. If your quality is not right, then it doesn't matter that you produce the results the fastest or the cheapest. If the client doesn't get the quality that you have assured them, then they would rather move their samples to somewhere else, even if it means they need to wait a little bit longer or pay a little bit more. Before we can focus on quality, we need to define what is this quality that we've been talking about. The definition differs from person to person. In general, it is a standard of something as measured against other things of a similar kind. The degree of excellence of something. We use this to compare things in our everyday life, be it cars, clothes, drinks. In most cases, a higher cost is associated with a higher quality. It conforms to a standard. We can't talk quality without talking about quality management system. Some examples of quality management system are the ISO 9001, and specific to the laboratory is the ISO IEC 17025. We also have good laboratory practices. So what is a quality management system? It is a systematic, integrated set of activities to establish and control the work process from pre-analytical through to post-analytical process, manage resource, conduct evaluation, and make continual improvements to ensure consistent quality results. Most of the quality systems are not mandatory. They are, however, a good idea to have a system in place to ensure that you can produce consistent quality results. When we talk of quality, people often use quality assurance and quality control interchangeably. However, there's a distinction between the two. The one system is defined as an activities to ensure a process are adequate for a system to achieve its objective. That is quality assurance. While quality control is defined as activities to evaluate a product or work result. What does that mean? It means one system, which is the quality assurance system, is a preventative system, while the quality control system is a detective system. How do we then define this? It means if you're putting in a quality assurance system, say you're deciding on you want to have an acceptance criteria for testing a sample. You will then define the criteria and put it in a procedure to say, for a sample to be accepted to be tested for this method, it needs to meet this criteria. For quality control, you would then have to evaluate when a sample comes in. Does the sample meet my criteria? If your criteria was that the particle size must not be greater than 75 microns, it means on the quality control side, you need to find a system, an activity that you're going to do to check if that particle size meet your set criteria from your preventative system. This is ensuring that if the sample has to be analyzed by this method and it comes in with the set sample size, then it means the particle size is correct and the method can be analyzed. If the particle size is not right, it will then be rejected. That is the difference between quality assurance and quality control. You put quality assurance first and define how your quality process is going to be. You then put quality control measures in place to ensure that everything that comes through meets the set quality control criteria. In the previous slides, when I spoke a little bit about quality management system, I introduced ISO IEC 17025, which is the standard specific to testing and calibration lab. If you look at the current version of the standard, which is the 2017 version, clause 7.7 is about assurance of quality. This clause is specific to assurance of quality of results. It says that the laboratory shall have a procedure to monitor the validity of results. This monitoring shall be planned and reviewed and shall include, where applicable but not limited to. It then lists different activities that a laboratory can do to monitor its activities. We will focus mainly on the first listed activity in terms of what the standard has listed, which is the use of reference material, or what we normally would refer to as QC material. There are times where you find that people will be using a QC material and not necessarily having looked at how do I actually choose a QC material? What are the things that you need to take into account, right? Let's just discuss some of those. Firstly, when you look at a QC material, you need to first understand, what do you need this for? What are you creating this material? What is it? Firstly, looking at what are you creating for, you look at aspects of the level of property. A property could be like a concentration level. So you look at what concentration levels do I need this thing to help me with in terms of my quality control system. You then would choose a reference material similar to whatever your sample range would be. There would be no point of view if you analyzing low levels in terms of ppm levels, and yet you use a reference material that is in grams per liter, for example. You also need to look at the matrix or the structure of your unknown and choose a QC material that is as close as possible to your unknown sample. This ensures that whatever the QC material information is giving you, you can easily relate that to your unknown. So if it's not the same structure, not the same form, how do you then make it speak to your unknowns? Stability is also very important. This determines your shelf life, even storage conditions. You don't want to have a QC that's available today and it works and tomorrow it doesn't, because you also need consistency so that you're able to ensure that you have consistent results and producing consistent quality of your results. So if you have a very stable QC material that you can use over time, be it a week, a month, a year, or even longer, that is ideal. What you look at in terms of also your reference material is the uncertainty at a stated confidence limit given and certified by the producer. So most of the time when you buy these quality materials, they would have a concentration level attached to it, and there will be also a stated uncertainty that was associated with that concentration. So that is all the information that you need to look at and say, okay, this will work for my analysis because it is in the same level as what I need to analyze. It is in the same structure, it's been prepared the same, it's stable, I can use it for longer, and the uncertainty given is also within my acceptable quality limits. There are reference material, and then there are certified reference material, CRMs. And that certified value has a lot to it. So how do we define just a reference material? This is defined as a material sufficiently homogeneous and stable with respect to one or more specified properties, which has been established to be fit for its intended use in a measurement process. That's a general reference material. We then move to defining a CRM, a certified reference material. This is defined as a reference material characterized by a metrological valid procedure for one or more specified properties, accompanied by a reference material certificate that provides the value of that specified property its associated uncertainty, and a statement of metrological traceability. So that is what a CRM has. It's a value of a specified property that would be like a concentration, an associated uncertainty, and most importantly, a statement of metrological traceability. This is where we end this presentation. In the next presentation, we'll go deeper into looking at the difference between reference material and the certified reference material. We'll look at how we actually prepare reference material. Reference material could be in-house QCs. What exactly are we supposed to do with them? How do we prepare them? How do we use them? Also looking at CRM. When you buy a CRM, what are you supposed to look at in terms of the certificate? What information is supposed to derive from there, and how do you actually use it effectively? So we'll discuss all of this in our next presentation. Thank you for watching.